In this video, we will write a function for deleting a node from a given linked list at a given position. So I'm using the same project here. Main function is already creating a linked list. Now before the main function, I will write on a function for deleting a node. So let us write a function delete, and it should take a pointer to a first node and index from which we want to delete an element. So inside this function, I may need few variables like a pointer to a node, that is tail pointer, and also to store a deleted element, I will take a variable x and in that I will assign -1. Now before deleting an element, I will check whether the indices are given valid or not. So the possible indices are starting from 1 onwards, as we have discussed on whiteboard. Indices starting from 1 onwards, and that will go up to the length of a linked list. So I can give the index from 1 to length. So here I will write on the condition that if index is less than 1, then it is invalid. Or if the index is greater than length of a linked list, that is for length of a linked list, we have a function called count. To that we will send a pointer p, which is a pointer to a first node. So if this is the case, that is either index is less than 1 or index is greater than count, then it's an invalid index. So I should simply return -1, that is element is not deleted. So or else I can say x also here. So element is not deleted. Otherwise, we can insert an element. So this is the extra condition I am showing here. This I have not discussed on whiteboard. Now, as per our discussion, here we have two cases, that is inserting first node or inserting any other node. So first of all, if the given index is equal to 1, then we have to handle it specially, that this is the first node. So if it is the first node, then I should make a q point upon this first node as this is the first index. Then I should take the data from first node and I should move the first pointer to a next node. Then I should delete the previous first node, that is q, where q is pointing. Then after this I should return x. The deleted element is in x. So this is the first case. Though the pointers used here may be different, so p or q, whatever the pointer is used, so logic is same. Next, otherwise means if it is not first index, then any other index. Then if it is any other index, then using a for loop, I should use p and q to move them and make a p point on an exact node which we want to delete. So for that, using a for loop, I need one more variable I. So here I will declare a variable I. Then using a for loop, I will move this pointer p and q. I assign 0, I is less than index -1 and I++. So already I have checked for valid index, so I don't have to check anything extra here. And every time q will move it upon p and p will move to next node. Then after moving p and q for index -1 time, p will be pointing on a node which we want to delete. So as we have already seen the steps, that q's next will be pointing on p's next. So now p will be logically removed from a linked list. Then in x we will take the data from p's data and then delete p, and finally say return x, the deleted value. That's all. So this is the portion of the code that we have already seen. Then before this I have added extra line, that is checking for validity of an index. Yeah, delete function is ready. Now let me check it once. Oh, see, the return type is integer type. Initially I wrote it as void. Delete return type is integer, the value we are returning, the deleted value we are returning. And this pointer q is a tailing pointer, so it can be initialized to 0. And for deleting nodes, I should use a function free instead of calling delete. Delete is a keyword that is in C++, but here we should call a function free. Yes, everything is perfect. Now let us go back to main function. Inside the main function, already I have a linked list with a set of elements here, that is 10 to 50. Let us delete 40 and check. So after creating a linked list, I will call the delete function and I will give the first pointer as a parameter and the indexes. If I want to delete 40, then it is fourth node. Like see, this is first and then second, then third and fourth node. Yes, I should give the index as 4. 40 should be deleted. And after that, when I display a linked list, I should not get 40. Now let us run the program and see. Yes, I am getting the nodes, that is 10, 20, 30 and 50. 40 is deleted. Let us check whether it is deleting fifth element or not. Yes, it is deleting fifth element also. What about the first element? Yes, it is deleting 10 also. That is 20, 30, 40, 50 we got. If I give index 0, then what happens? Nothing is deleted. That is 10 to 50, all the elements are as it is. Nothing is deleted. If I give the index as 8, there are no 8 elements here, then it is invalid index. So it's not deleting anything. All the elements are as it is. I'll make one more change here. When I am calling delete function, I will directly print its result. That is deleted element percentile d and slash n. So whatever the element is deleted, it will display that element also. Let us run it again. Deleted element is -1, means it is invalid index and I am getting all the elements as it is in a linked list. So instead of 8, I will give the index as 2. So 20 should be deleted. Yes, deleted element is 20, then I am having 10, 30, 40 and 50. Yes, it is perfect. So that's all. In this video we have completed delete function. See here we are writing all the functions upon a linked list, so it is becoming a single big program useful for linked list. So further in our subject, in our course, wherever we require a linked list, we will be using this as a header file and we will be including it and we'll be calling all the functions whatever we needed.